Hi everyone, this will be your video for interpreting graphs of functions. Most of this should look pretty familiar if you've seen it before, but we're just going to take a few minutes and just go everything again. So starting off, we're going to talk about increasing and decreasing behavior. So I always reference my little man, and I always have a little man on my graph, and he walks left to right. So your little man will be able to help you figure out if he's walking upwards, it's going to be increasing. Downwards, it'll be decreasing. If it's staying flat, it's constant. So let's use this idea of this little man, or use the idea of walking across the whole graph yourself, and we can figure out these intervals for us. So let's start with increasing. As I'm going left to right, I can tell that we're increasing through this piece. All of a sudden we're constant. I'm not going to highlight that. Now I'm starting again here. We're increasing again. And I'm decreasing until we get to 4, and then we're increasing again. So what's nice about using either some sort of like highlighting technique or color coding, it'll help you visualize exactly where you're increasing or decreasing, and then you just have to write your intervals yourself. So if you take a note at the bottom of the screen, your intervals are written in X values, using your X values. They might look like points, that's fine. We'll get into detail about whether or not to use parentheses or brackets at a different point, but right now I just care about your X values. So we're going to list them. So I'm going to list them under the words increasing, and I'm just going to go across. So our first highlighted section is from the X values of -6 to -4. Then as we go along, we have an increasing section again between -2 and 2. And again, we have our third increasing section, which is between 4 and 6. So do be careful if your graph either has points, endpoints like ours does on this example, or if there's arrows. If there's arrows, it's increasing forever at that point, so you would use infinity instead of 6. Just to give you a little idea of what that would look like, that would be if your graph was extending here. That last interval instead would just be 4 to infinity. Okay, so it's a whole different idea there. Make sure you can tell a difference if you have an endpoint or if it's going to continue forever. Okay, so let's talk about our decreasing. So let's erase this extra part so we don't get confused. Erase this arrow. And now we're going to talk about when are we decreasing. So again, using the same concept as our little man, we're traveling along our graph. Now we know the parts that are already highlighted in purple are increasing, but you can still, evaluate what's going on. So we're increasing, we're staying flat, we're increasing again, and then we do get a nice decrease here. There we go. And you can see that that's it, right? Our graph is done after that point, after our next interval, and we can just list the X values where we're decreasing. So we are decreasing between the values of 2 and 4, okay? That's all you need to write for this, the intervals where it's decreasing. Now, obviously, we do have this one flat horizontal section, and that's going to be called your constant, right? It's not increasing, it's not decreasing, it's just staying flat, it's just staying the same. So we're going to write that interval as well, and those are between the X values of -4 to -2. Remember, these are not points, these are intervals. These are our X values. We're just kind of listing the X values almost as if it was just a number line on what is increasing and what is decreasing or staying the same. Okay, next up, positive and negative. Way even easier than the last one. It's positive if it's above the x-axis, and it is negative if it's below. So I'm going to go through again with my highlighter, and I'm going to say, okay, everywhere that it's above the x-axis, that is my positive. So I'm going to going. This is positive, it's positive, there we go. Now you notice that this first piece over here, I did not highlight purple because that's actually below the x-axis. So that's going to make that negative, okay? So it's really simple, it's just if it's above, it's positive. And you can think about how those y values are positive. If it's below, it's negative, and that's where your y values are negative. This should start coming together for you, especially as we're in pre-calculus, we're a little more advanced now. This should make a little more sense. So we're still going to write our answers in intervals. Our intervals are still using our X values. And if we look at our purple section that I've highlighted, that's going to be between -5 all the way as we travel along. Oops, didn't mean to write that. Let's use this pointer instead. So from -5 all the way until we get to the x value of 6. Our graph does end here. If you had an arrow, you would use an infinity symbol. So it's going to be between -5 to 6. And then we can do the same thing for our negative. We can say, okay, it's between -6 and -5. We're going to have a negative value, right, below the x-axis. All right, so back to some basics here. We have our intercepts. Intercepts are where a graph is going to hit the x or y-axis, depending on what intercept you're looking for. So remember that with an x-intercept, which we're going to do first, you could have no x-intercepts. You could have one x-intercept. You could have 25 x-intercepts. There's no limit on how many that you can have or not have. So our graph here, and again, I use my little man to help me out. And my little man's walking across. Now he's going to be walking across my x-axis because I'm just trying to focus on where is my graph going to intersect the x-axis. So as I'm traveling across, I can see it's going to intersect right here. Keep going. I don't have anything yet. Oh, here over at 4, we have another intersection. So that means that our x-intercepts are going to be -5 and 4. So you could write them, for instance, if it was like the Google form, you could just list -5 and 4. You could write these as points, and this point value would be -5, 0, and 4, 0. You know, those are the best way, but really whatever gets your point across, we'll work together to figure it out. Now let's talk about y-intercepts. The one difference between x and y-intercept is that you can only have one y-intercept. Now the reason why is that if you were to have 2 and they would be vertical on top of each other, you wouldn't have a function. So you only have one y-intercept. Ours occurs at 3. So we could write a 3 down here. Or you could write it as a point. Now remember, it's opposite now. So our x value is 0 and our y value is 3. Very important when you're making your points where the zeros belong. It makes a huge difference whether or not it's going to be on the x-axis or the y-axis. All right, so now we've arrived at extrema. So this is something that, again, you might not have heard it as this word as extrema, but minimum or maximum, that should be a familiar phrase for you. And when we're talking about a minimum or a maximum, we're talking about just locally, right? We're not saying absolute minimum or absolute maximum. We're just asking for locally around a point, where do we have any minimums or maximums? So minimum is obviously the value that's less than everything else around it. Maximum is obviously going to be the value that's greater than everything else around it. Now personally, I always use the phrases the bottom of a valley or the top of a mountain. And that should make sense if you think about maybe like a parabola. You either have your vertex on the bottom or on the top. So we're going to look for maximums first, and that's going to be a top of a mountain, top of a mountain type thing. So when we're looking for maximums, we're going to say you can still use your little man and travel around. Now some people do get tricked and they would say, okay, -4 looks like it's a maximum. It's like a point where it stops increasing. But if you notice, right next to -4, there's another value, right? All of these values are the same. That's the whole idea of being constant. So this right here is not a maximum. You can think it's only a maximum if it's going to be switching between increasing and decreasing, and it'll only be a minimum if it's switching between decreasing and increasing. So because this is constant right here, this is not a maximum value because all of these values are the same. So that is not a good answer for us. So let's erase that so you don't get tricked. I just wanted to explain that. And let's find our actual maximum here. So right here I can clearly see that this point is above the rest, and that's our only one right now. So we have the point 2, 4. Now another way you could write this, you could also say you have a maximum of, and now this is where it does get tricky, it's going to be your y value. So maximum of 4 at your x value, which is 2. Now let's talk about minimums. So our minimum is like that whole idea of the bottom of a valley. And again, you can see that we have one over here at 4, 0. Because if you look around it, all of the other points are greater than it. So this must be the least point, right? The less value. So for 0, we could write that out as a point. And if it said what's the minimum, you could just write that for 0. Or if you'd like to write it in words, you would say a minimum of 0, okay, because that's our y value, at 4, because that's our x. Okay, so remember, this is our y, this is our x, same thing down here, this is our y, this is our x. Okay, so now we're at function value. So function value, you can think of it as either like your input or your output value. It really does depend on what they're asking you. So what it says on the screen here is that a function value is considered the output for a specific input, so a number that you're either inserting into a function or finding the point on a graph. You could also reverse that and find an input for a specific output. So let's break this down. So first we're going to look at f of 2. So what that means to me is that I'm going to my graph and I'm going to go to my x value of 2, and I'm just going to find where my point is at. So at 2, my point is at 4. So my input was 2, so that means my output is 4. Remember, your input's your x value. Okay, that's usually in your f, like your function notation, like f of x. So our input, and then 4 was our output. All right, let's look at the green one. So now they're asking for f of -6. So we're going to do the same thing. We're going to go along our graph. We're going to find -6. -6 is right here. And the point there, so we find the point on our graph, and it's at -6, -2. So we could write this over here. We have -2, so we have our input again. And then we have our output. So if you look down here at the orange question, you will have a few like this on your assignment for this week. And what's different is now they're giving us the output. So we need to think, and if you'd like to think in words, which I really do like to do that a lot, to really understand what we're being asked when we see these algebraic expressions, you're thinking of what x values will give me 0 as an output. Okay, so that's really what this question is asking us. They're telling us that we have some sort of output at 0. What x values are going to get us there? So what you can do is you can go along your graph and we're going to find all the places where our f of x or our function equals 0. So personally, what I like to do is I like to highlight across that line. And then we're just going to figure out the x values that occurred here. So this does technically happen to be on the x-axis, which is going to be the same as our x-intercepts. So we'll do another example after just to clear this up. So right here you can say, okay, so if I plugged in -5, that's going to give me an output of 0. And also if I plug in 4, that's going to give me an output of 0. Notice how this is not a point, this is not an interval, there are no parentheses around this, it's just a list of numbers. Let's do one more like this last one just to clarify it. So we'll call it D, but it's the same idea as C. So we're going to say f of x equals, we'll choose 3. Okay, so this is telling us that our output is 3. So what I'm going to do, and let's switch gears, I'll use blue here. Okay, so my output is 3. I'm just going to scan across when my value is 3. And I'm looking for all of the times where my graph is going to hit 3. So it's going to occur right here at x equals 0. It's also going to occur right here, which we can estimate to be like 2.5, somewhere around there. Because those are the x values. So these are the x values that gave an output of 3. Okay, so it's a little bit opposite than the pink and the green. You're thinking of backwards now. You're saying, okay, this was my output. What was plugged in to get this? Or what was the x value that gave me this output? Okay, so last up is domain and range. And I know this is everybody's favorite. right? Because we learn this every year and we pretend like we know it, and then we get to a point where we're actually asked about it and we have no idea what's happening. So domain and range is something that never goes away. In fact, it stays the same sort of consistency. It stays the same level of hardness through all courses. You could be in calculus or you could be in algebra 1, and you're using the same skills here. So let's really break down how we find domain and range. The first thing you can think about is, think about this simply. The domain are going to be the x values covered by your graph. Your range is going to be your y's. So our graph right here, we do have endpoints. Okay, so we're going to do this two different ways. We're going to do this with endpoints and with arrows. So we're going to do that on the next page. So first we're going to do endpoints. So when I'm looking here and I'm looking for my domain values, I can say, okay, what x value is my graph starting at? So I can see that my graph is starting at -6. So we're going to write this, we can do it as an interval. Usually I'll use like a D to represent domain. And we're going to be starting at -6. And as I'm going across, I'm just kind of like scanning and say, okay, like I have a point at every x value, right? I could go across and I can find a point at every x value up until +6. Okay? And that's because you can almost think like it's continuous. I could trace it with my pencil. And at +6, it ends. Okay? There's no points after +6. There's no points missing in the middle. If there were, you would not include them. So it does end at 6. So we're going to do from -6 to 6. So now let's talk about our y. So let me put some dotted lines. It's almost like bookends if you want to think of it like that. So now that we're talking about range, we're going to kind of switch gears and talk about our y values. So I'm going to put a dotted line at my lowest y value. So my lowest y value, and I can use an R for range, it's going to be -2. And then when I look and I'm traveling through my y value, so now we're traveling vertically. At every y value, I can find a point. Okay, that's our goal here, is to make sure that there are points at all these values. So like you can see I'm checking, like at 1, I have points. And I have points all the way up until we get to this highest y value that we have, which is 4. Okay, so I'm just going to put a dotted line here to show you where it gets cut off. So our graph ends at the y value of 4. I don't have any points after that. I don't have any points below -2, so that means my range, or where I could expect to see my graph, is between the values of -2 and 4 on my y's. Think of it as a way of, if you should be cutting your graph or your graph paper to only include your graph, where would you be cutting it, right? What x values are included? That's your domain. What y values are included? That's your range. So let's look at what this would look like with arrows. You know what, we can do it right on this page, and I'll do it in blue. So now we have this different question here, and there's no longer endpoints. So what's weird about this is you can't really list the values. If you think about it, and if you keep imagining zooming out of this graph, you would keep zooming out and you would keep seeing more values, like it would never end. So what that means is that because this has an arrow on both sides, and I don't see any gaps in here, right? There's nothing missing. We can assume that it's going to continue forever in some sort of way. And we are going to start using infinities. So this is a different problem. This is now in blue. Okay, so make sure you're paying attention here. So our domain, when we have arrows on the end, so this is with arrows. Okay, so with the arrows on the end, our domain, think about the smallest x value you'll have. So remember, x's are on our number line. So if I were to keep going over here on my x-axis, I could keep continuing. I can keep zooming out. I can keep going further and further negative. So that means that I could go all the way to -infinity. So we can write this as an interval between -infinity, and as we travel along, we're traveling, we don't stop, we don't have any gaps, and we're going to continue on forever. So we're going to go between -infinity to +infinity. Okay? And we could also write this as all real numbers. You could also write this using this symbol for all real numbers, which is a capital R with 2 lines. Okay, so now let's talk about our range. So our range are going to be all of our y values. So as we're traveling through our y-axis now, we're switching gears looking at the y-axis, we can assume that if I were to keep zooming out and keep zooming out, I would continue to have values. I would continue to have y values. I would keep going more and more and more and more negative. Same idea as the domain. It's going to be negative infinity. And then as we continue on, traveling through our graph, now notice that our y values, it looks like they might stop here, but because there's this arrow on the end, my graph is going to continuously increase. It's going to always increase. It's going to keep getting greater. And it's just never going to end. It's just going to end up at infinity. So we're going to use a positive infinity again. So again, you can write this as all real numbers, or you can use that shorthand notation. So it's not always negative infinity or infinity. Sometimes it might be one or the other. For instance, I'll do one more example on here, and I know you're just so excited to see it. But the last example is going to be something similar that you'll have on your Google form. And that would be like maybe one arrow and one endpoint. So now it's a little bit more complicated because it's not just all real numbers. It's not going to continue everywhere. And we're only going to have one endpoint and one value. So we're going to do this one in yellow. We're going to talk about our domain. So this is with endpoints and arrows. Okay, so our domain. So these are our x values. Now again, we're going through our graph. We have an endpoint here. That means that -6 is where we're starting. We don't have any values other or lower than -6. So we are going to start at -6. As I'm traveling along my x-axis, I can see that I have points for every x value. There's no gaps, there's no spaces. I'm continuing, and now we are using this arrow right here. And I can see that it's going to just continue. It's never going to stop on my x-axis. So I started at -6, and I'm pretty much just going on forever to infinity. So the way I would write that is I would start at -6. Now think of that word the comma like the word 2. So -6 to infinity, because it's never going to stop. Let's do our range with this one. So our range will be our y values. Again, there's a point here. I don't have any y values less than -2, so that means that my range is going to start at -2. And then we're going to travel through our graph again. Now, it might look like this might be the end of our range until we get to the end, and we see it's pointing upwards, right? It's going to always be increasing. It's going to go towards the value of infinity. So what we can do is we can write infinity.